These are the problems worked from your last contest, and so you'll find a lot of interesting things here that you can do. All right, so number one was if f of x, let me pull in the question. All right, so here was number one. F of x is 1 minus 2x squared, and then you have this ridiculous like f of 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 forever and ever f of 1 over root 2, where f appears 2,119 times, which means you're doing f of f of f of f of f inside 219 times. And so obviously there's going to be some pattern, so just jump in and start. So f of the first thing that you see is 1 over root 2. Gives me 1 minus 2 times 1 over root 2 squared. We're looking for a pattern because they wouldn't want us to do something that ridiculous. So that's 1/2, and 1 minus 1 is 0. So now I find f of 1 over root 2, which gives me f of 0. And if I find f of 0, I get 1. So now I know f of 1 over root 2, f of that, sorry. So now you know f of 1 over root 2 is 0. And so this is 0. And now you know f of 0 is 1. And f of 1, if you fill it in here, you get 1 minus 2 times 1 squared, you get negative 1. And so I really just keep finding the inside. So let's just find f of negative 1 and see what happens. If you fill in f of negative 1 right here, you get 1 minus 2 times negative 1 squared, so you get negative 1 again. And so you see what happens after a while is you just keep finding f of negative 1, it collapses to that. So f of f of f of f of f of 1 over root 2. Let's see what we've done here. Alright, so f of 1 over root 2 was 0, I think, yeah. And so then I had f of f of f of f of 0, and f of 0 was 1, so I had f of f of f of 1, and f of 1 was negative 1, so I had f of negative 1, and f of negative 1 is negative 1, so I had f of negative 1, and f of negative 1 is negative 1. So what that means is after these first few, you reach a point where all the ones after it, you're just doing f of negative 1, which is negative 1 every time you get to that point. So the answer to that one is negative 1. Might look up back over that and see the pattern. All right, number 2. Let R be the inner radius, so be very literal. I don't know if they gave you a picture, but you have this like toilet paper roll. Anyway, you've got, I can't really draw it, but you had a picture. In fact, I probably should have pulled the picture off of, I hope that's what they gave you. I can't really see what they gave you. I think I've already logged out of the Math Madness site, so I'm not sure what you see. But anyway, you have this toilet paper roll. If you look at it from the top, it looks like this. And if you look at it from the side, it just looks like a cylinder. But of course, it's hollow on the inside. All right, so R is the inner radius of the toilet paper. So the inner radius of the toilet paper is R, and the outer radius of the toilet paper is capital R. So you have this. So you have little r, and you have capital R. and this is the top of the toilet paper. All right, so the volume of the paper roll, so let's find the volume. The volume of a cylinder is pi r squared h, but the volume of this wouldn't have the middle in it. This would be hollow, and so you've got to also subtract the other pi r squared h. Now you have two radii, and specifically, you know, the outer radius is capital R. So I have pi r squared h minus pi r squared h. Always keeping your eyes open for critical thinking tricks. Later on in the problem, oh, let's read it, sorry. We'll insert it. Okay, so this one. I don't know where it put it. Here it is. Okay, so we have this. All right, now it tells me that the volume of the toilet paper roll is equal to the lateral surface area. Equal to the lateral surface area. And so I'm going to say equals, and what the lateral surface area is the lateral surface area is just like the outside of your toilet paper. So it's like this would be the lateral surface area, would be the outside, but you also have this inside that has a lateral surface area also. Alright, so a lateral surface area without the top and the bottom would just be like a hollow can, just like a hollow cylinder, and then on the outside of that you have another hollow cylinder. This would be your surface area of the inside and your surface area of the outside. So the surface area, lateral surface area, I felt like that wasn't really very clear, but it would be 2, sorry it's not writing. So that would be 2 pi r around the base of it, and then h would be the height, and then plus 2 pi r h for the inside lateral surface area. Again, I thought this problem was a bit faulty and kind of hard to understand, but let's keep going looking for tricks. Alright, tricks, the pi's can all cancel out, as can the h's. And look what I have left. R squared minus R squared equals 2R plus 2R. I can factor this into R plus R, R minus R, difference of squares. You're always looking for tricks. And I factored a 2 out on the right hand side. This cancels, and so now I know 2 is equal to R minus R. And the question was, oh, I'm sorry, and I forgot something. I forgot something important. Oh, but I can pick it up here. All right, so another thing that they said was the ratio of R to R is 2019. So big R to little r is 2019. So R is equal to 2019 R. So when I put that in here, 2019 R minus R equals 2. That gives me 2018 R, subtracting of 2019 minus 1. So R is 2 to 2018, or 1 to 10,009. And this is A to B. They love these ratios. And so if you add them together, you get that 1010, which is the answer choice. Or you didn't have multiple choice, so that's the answer. These were like considerably tougher, a whole lot more like AMC and the competition math. So be on the lookout for things like factoring and patterns and things like that. I hadn't had to do that much, but we do now. All right, number 3. Number 3, let me insert that. So we have P and Q are externally tangent. That means they're not like this, they're like this, externally tangent. Okay, one of them's a lot smaller than the other as you read further along. So let's make this one really big. I found I needed a lot of room for this in my drawing. So this is P, and so Q's like over here. It's had a lot going on. It may have been one that I would skip at first. The radius of P is 12, and the radius of Q is 2. So this is P, and this is Q, and this is 2. Which means if I kept on going out here, this would also be 2, which is important. PTQ is where it's externally tangent. So the point of tangency is right here at T. So this is PTQ. And we can see the length of it. All right, so PTQ extended intersects Q at B. So if I get to PTQ and I extend it, then it goes to B. So I actually know PB is this 12 to 2 and another radii, so PB is 14. We'll use that in a little while. A lies on circle P such that AP is perpendicular to PB. And R lies on AB such that RT is perpendicular to PB. So here's A, B, and this circle, it would help, it should be a little bit smaller. And RT is perpendicular to PB. So this is RT right here. These are perpendicular. S is the intersection of circle Q and AB. So I'm on this part right here, looking for where S would be. All right, so it's the intersection of circle Q, which is right here, and AB, which is right here. All right, so this is S right there. The length RS, so we're looking for this length right here, can be written in simplest form of M over N. So somehow we have to find this RS. And we have similar triangles going like all through here. So I have like this similar triangle, and I have this similar triangle. There's actually something that you should look out for here. There's some 3, 4, 5 triangles going on in here with right angles. The way that we know this is 12, so this is how we prove it. This big triangle APB, this one's 12, and remember we went this way, and this way, so this one's 14. This one is 3 times 4, and this one is 4 times 4. And so this one would be 5 times 4, so I know this one is 20 in case I need to know A, B is 20. All right, now that we've got the ratio set, we know that they're proportional, and we know this part right here is 4, and so this part's 3, and this part's 5, another 3, 4, 5, in proportion with this multiple of 3, 4, 5. So I just found this is 3. And I know that this whole thing right here, which I don't really need yet, is 5. This whole distance is 5. All right, now we have another triangle in here. Let's see if I got all of my perpendiculars. Let's see, there's one more perpendicular from S. Oh, if you have this point right here from S to Q, I'm sorry, from S to T, in circle Q. So let me undo that. And I'm trying to think, I can't remember why I knew that was perpendicular. S to T. Oh, okay, we know that's perpendicular because of this 180 degree angle right here. And so this inscribed angle is half of that. So a lot of geometry going in here. So we have another right angle with angle, angle. So with this big triangle, they both have a right angle, and they both share angle B. And so I have another 3, 4, 5 triangle. All right, now I know this, so I have this 3, 4, 5 right triangle. And we already know that this side is 4, so the hypotenuse is 4, but I have a 3, 4, 5 ratio going on. Like I said, this one takes a while, but you move around pretty fast once you see it and have done some of this before. So now I'm looking at this side and this side. All right, now which one would be the 3 and which one would be the 4 is kind of the question. I'm sorry, which one would be the smaller and which one would be the larger? And I haven't, this one would be smaller, this one would be larger, and this one would be the hypotenuse. And so I know that this, I'm wanting this side right here. I'm wanting this right here. Okay. So now I'm going to say, in a 3, 4, 5 triangle, let's see how I'm going to say this. I'm going to say x is to 4 as 4 is to 5, because this should be a multiple of a 3, 4, 5 triangle right here. I don't know if I'm explaining that very well. But the ratio of the hypotenuse to the longer side should be a 4 to 5 ratio. So the hypotenuse and this longer, and the one of the two longer sides, the one of the sides that's longer should be a 4 to 5 ratio. So I'm saying in a 3, 4, 5 triangle, this should be a 4 to 5 ratio. And so I want to know what this is over 4. So hopefully you got that. If I multiply both sides by 4, I get x is equal to 16/5. All right, so this distance is 16/5. Again, I agree it's a tough problem. This whole thing we found a long time ago was 5. They just want this part of it, RS. So I'm going to take this whole thing 5, subtract off the 16/5 I just found because we have RB. RB we know is 5. We know this part of it is 16/5. So if I subtract those two, I get the little piece that I need, RS. So that gives me 25/5 minus 16/5 is 9/5. Again, they like this ratio thing. So the ratio is 9 to 5. And then if I add them together, I get 9 plus 5, or 14. It was a lot of explaining, but once you get used to watching for patterns, there's these 3, 4, 5 triangles embedded in there. That was probably the hardest one. All right, let's go to number 4. All right, number 4. Let me insert it. All right, the rightmost digit, now that is ridiculous. So let's just start off looking for a pattern. 2019 to the first is 2019. 2019 squared is 2019 times 2019, which you can multiply on your calculator, but I'm not going to. A lot of these contests we're going to do aren't going to have a calculator anyway. That's 17, 1. I think I multiplied that right. Then 0, and then 1 times 9 is 9, 1, and so on. I'm not even going to do any more because I need the rightmost digit, and that's a 1. And so I don't even know what it ends in, blah, 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 but it ends in a 1. So then if I have 2019 cubed, that means I have something that ends in a 1, I don't know what it is, times 2019. And you can see that digit would be 9 times all of these numbers, and then you would have a 0 and 1 times all of those numbers, and so on. And so your digit is something, 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 9. And then if you multiply by, it ends in a 9. If you multiply by 2019 to get 2019 to the 4th, you can see that's going to start with 81, and then the next row is going to have a 0 on it, so it's not going to affect your rightmost digit, which is 1. And so all the odd powers end in a 9, all the even powers are going to end in a 1, and so the odd powers end in a 9, so its rightmost digit is 9. So that's a great way to do contest math. That's a really good one. As is the next one. This is key. So let me insert number 5. 1, 2, 3, 4, 5. Okay, I've never even really seen a proof of this, but if you find for any polynomial, I'll write this out. This is so important for our contest math. For any polynomial, the sum of the coefficients, and so if you know this, wow, it goes so much faster. The sum of the coefficients is P of 1. This is super important. So you could have multiplied that all out, which would have been a nightmare, not too bad, but been gross. All you have to do is do P of 1. All right, so 1 plus 1 is 2. I can stop here because 1 minus 1 is 0, and it doesn't matter what else I get out here. All of a sudden, the sum of the coefficients is 0. Let's take just a different polynomial to look at, like x plus 3, x plus 2. P of 1 is 4 times 3 is 12. Now let's actually do it out. That gives me x squared plus 2x plus 3x plus 6. And so if you add up your 6, your 3, your 2, and your 1, you get 12. If you say P of x is x minus 2 squared, you get x squared minus 2x plus 4. P of 1 is 1 minus 2 squared, so you get 1. And if you add up your coefficients here, you get 1 minus 2. Oh, well, that's not working. Something's wrong. Oh, it's 1 minus 4x plus 4, sorry. Okay, all of a sudden it wasn't working. So you get 1 minus 4 is negative 3 plus 4 is 1. I don't really like the sum of the coefficients, but when they call this the coefficients, they really mean 6x to the 0. You may have wondered what to do about that constant. So let's remember P of 1 will always find us the sum of the coefficients. Very similar to that, something I've told you but not written out for you. What if they say, what is the remainder of a big long polynomial, P of x or f of x or whatever they call it, x to the 101 minus 2x to the 48th plus 7. And they ask you what the remainder is if you divide that by x plus 1. And if you try to do long division, it'd be horrible. Synthetic division won't even work either because you would have to have your coefficient 101, then you'd have to have a 0, 100, 0, 99. Don't do that. The remainder is always equal to P of the root of this will, like the root of the bottom of this, which gives you negative 1, like what makes this 0. So if you put negative 1 into this, you get negative 1 to the 101 minus 2 times negative 1 to the 48 plus 7. So this wasn't one of the questions, but you get negative 1 minus 2 plus 7. So your remainder would have been 4. So what I mean by that is if you have P of x is equal to x to the third plus 2x squared minus 7 over x minus 2. I could divide it, x to the third, let's do synthetic division, 1x to the third, 2x squared, 0x, and negative 7, and put this 2 into it. Let's divide. Bring down your 1, 2, add, multiply, add, multiply, add. So the remainder's 9. But I could have just said P of the root of this, which is 2. That would give me 2 cubed, which is 8, 2 times 2 squared, which is 2 times 4 minus 7. So this gives me 16 minus 7, which is 9. So if you need a remainder and it's divided by a linear factor, you could just find the root of that factor and fill it into the top, and you will know the remainder without any stress. Let's go to number 6. All right, number 6. 1, 2, 3, 4, 5, 6. All right, number 6, you have, here it is, x cubed plus y cubed. To factor a cube, you have a little parentheses and a big parentheses. You figure out what's being cubed, which is x and y. And you square the front, put it in the front, square the back, put it in the back, multiply them together, and put it in the middle. So let's do that again. Okay, to factor a cube, you have an a and a b. Square the front, put it in the front, square the back, put it in the back, multiply the two things together and put it in the middle. The last sign's always plus. There's always one minus sign, and it's dictated by this. Right, that's a plus, so this will go plus minus. The example I gave was minus, so this will go minus plus. All right, so let's start over. And by the way, I would factor this, and just by habit, or by doing contest math. This would be an x and a y. So square the front, put it in the front, square the back, put it in the back, multiply the two together, put it in the middle. The last sign's always plus. And since that's a plus, it's going to be plus minus. That equals 84. Now this one I'm going to take and factor out a y, and that gives me x, y plus x. Equals 7. So I know that y plus x, or x plus y, equals 7 over y. So I'm going to sub that in for x plus y. Always look for a group of numbers. So I'm going to have this x plus y from the front one, and that can be subbed in with 7 over y times x squared minus xy plus y squared equals 84. Now watch what I want. I want to know what that is. Looking for a group of letters. So I'm actually going to leave this 7 out of it for a minute. And I'm going to distribute this 1 over y. That gives me x squared over y minus x plus y. So I'm kind of thinking this is 7 over y, and I'm putting this y underneath each one of these. I'm distributing it without the 7. Again, I guess contest math. So I have x squared over y minus x plus y equals 84 divided by 7, which is 12. And so this whole expression equals 12. Again, a great contest math scenario. All right, now let's go to the next one. Number 7, I think. All right, another one that seemed a bit ridiculous. So there must be some sort of pattern that I'm supposed to pick up here. Okay. So you know f of 1 is 0, f of 2 is 2019, and f of anything after the third one is you subtract f of n minus 1 minus f of n minus 2. In other words, if you want the third function, if n is 3, this is going to be f of 2, and 3 minus 2 is f of 1. If you want f of 4, if this is a 4, this is going to be a 3. And if f is 4, this is going to be a 2. So what you see here is to get the third term, you subtract this first one from the second. You subtract the 2 terms before it. If you want the fourth term, subtract the third and the second. So this is what we call recursive. So to find the third term, I'm going to subtract these two, f of 2 minus f of 1, and I get 2019. So I'm actively looking for a pattern. F of 4, I subtract f of 3 and f of 2, and I get 0. f of 5, I subtract these two and I get negative 2019. F of 6, I subtract these two and I get negative 2019. I'm sorry, I went too far down, just a minute. Okay. F of 7, I subtract these two. Something from itself is 0. F of 8, 0 minus a negative is positive. F of 9, this minus this is 2019. F of 10, 0. I just wanted to establish my pattern. It repeats itself every 1, 2, 3, 4, 5, 6 times. And then it starts over again, 0, 2019, and so on. So it comes at me in groups of 6. And then by F of 12, I would have reached the end and start over again. So what I decided to do was take F of 2019, so the 2019th term, and divide it up into groups of 6. All right, I have a remainder of 3. So what that means is, thank goodness I quit writing it down, because it's going to go through this cycle 336 times. And then with a remainder of 3, I'm going to go 1, 2, 3 more and land at 2019. Okay. All right, and then the last one, number 8. All right, so number 8. Hang on, I'm sorry, I was making a video, but maybe more info. All right, so on number 8, you have the square root of y minus x squared equals y minus 1, and the square root of x minus y squared equals x minus 1. It gets kind of messy to multiply it all out, and sometimes it's hard to decide what to do, but I played around with it some and decided to square both sides. So if I square this side, I get y minus x squared, that was already there, and this becomes y squared minus 2y plus 1. Then I squared both of these, and I got x minus y squared was x squared minus 2x plus 1. And then quite honestly, looking for this answer, I added these two because I thought if I add, I would get x plus y and some of this stuff might cancel out, but it got worse rather than better if you do that, like nothing really canceled. And so I tried that, and so then later on I went back and thought, well, what if I subtract them? Because it looks like there's so many like terms. So that would give me, if I subtract these two items, that's going to give me y minus x. I'm going to have negative x squared minus negative, so plus y squared. On this side, I'm going to have y squared minus x squared. This is going to be negative 2y minus negative 2x, and 1 minus 1 is going to be 0. So, then, I can't remember what I did after that. I knew somehow that y equaled x, and I can't remember how I knew that. Let's see. Let me look back at my work. See, I can't remember why I would have this. Y minus x equals negative 2y plus 2x. And so I had y minus x. If you factor out a negative 2, that leaves you y minus x. Oh, no, sorry. I decided to do this. I added this over here and I got 3y equals 3x. So I knew that y equaled x. I just can't remember right now how I got that piece. So let me look back and see how I got that piece. Because I wrote all over my paper. Let's see. Okay, well, I guess I'm going to get that from this. Maybe that's why I forgot. We'll see what happens. I'm sorry, I didn't go forward. All right, so the x squareds cancel, and y squareds cancel. So on this side I have y minus x. Oh, and on this side I have negative 2y plus 2x. I should have kept going with what I did here when I subtracted. Again, the reason to subtract is you cancel some things. And so then that took me here, where I was. So it gives me 3y equals 3x, so I know y is x. So sub it into one of these. So everywhere there's a y, I'm going to put an x, or an x, I'm going to put a y. It doesn't matter. So I have x minus x squared equals x minus 1 because y equals x. Square both sides. X minus x squared equals x squared minus 2x plus 1. So if I get everything equal to 0 here, I get 2x squared minus 3x plus 1. And then I factored that into 2x times x, 1 and 1 minus minus. So my two solutions for x are 1/2 and 1. Now, if you fill in 1/2 for x, check them. If you fill in 1/2 right here, or right here, I guess this is a better place to put it in. 1/2 minus 1, you'll get a negative, and then enter the square root under the real numbers, which I've kind of written over it. I couldn't have a x is 1/2 because that would give me a negative answer to a square root. Okay, so therefore I knew x was 1, and if x is 1, then y is 1, and x plus y is 2.